Hello again, class. So in this lesson, we're going to relate the standard form and the factored form of a quadratic function. So at this point, you should have completed the investigation using Desmos, and there's some things that you should have noticed using or from the investigation. So you should have noticed the y-intercept, which you could find in the quadratic function using standard form. Okay, so if we go back and we take a look, these values here were the y-intercept. And you should have noticed that the axis of symmetry came from the mean of the x-intercepts, or it was right in the middle, always, of the two. And you should have also noticed that factored form gives you those x-intercepts. So we're going to now use this information to solve problems and answer questions. Okay, so back in Unit 2, we looked at the vertex of the quadratic form, and that was very easy to pick out because we were working with the vertex form for a quadratic function, which is y equals a x minus h squared plus k. And in this form, we just picked out the vertex. The vertex was hk. Okay, so that was back in Unit 2. So in this unit, we're going to compare the standard form with its factored form. So with the standard form from that investigation, you should have noticed that this value c always gives you the y-intercept. Now another way to find the y-intercept is to set x equal to 0 and solve the function. So if I evaluate f of 0, put zeros in everywhere there's an x, that will get rid of this term, and it's going to leave me with c anyway. So I could solve that algebraically as well. So what values do a tell, or what does a tell you? Well, a tells you all the same information that it did back in Unit 2. It's exactly the same. So we know from A that when it's positive, it's going to open up, or parabola will open it up. It also tells us if there's a vertical stretch or compression, and if there's going to be a reflection in the x-axis. So again, it opens up when positive. It tells us when it opens up, we know that it will have a minimum value. When A is negative, we know it's going to open down. And we know it will have a maximum value. There's two pictures that you can draw to help remember this. So if I draw this happy face here, the value of A is positive, I can see it opens up and has a minimum value. If I draw this picture with the sad face, we can see that A is negative and it opens down. There is a maximum value. So a minimum value when A is positive and the maximum value when A is negative. Okay, and we'll jot down the rest of that information. So the other pieces of information that A gives us is that there's a vertical stretch. It could also be a compression. And if there is a reflection in the x-axis. And that happens when A is negative. We'd have a reflection in the x-axis. Now, in factored form, A tells us all the same information. So I'm not going to write in the same detail. I'll just jot it down quickly. So it tells us the vertical stretch, or if there's a reflection in the x-axis. It tells us the direction of opening. And whether it has a max or min. In this form, R and S are the x-intercepts, and you saw that in the investigation. So R and S are the x-intercepts. Our H value, if you remember back from Unit 2, h was the x-coordinate of the vertex. The h value is right in the middle of the two x-intercepts. So in order to find a middle value, I can find the mean of the x-intercepts. So to find a mean, I add my two numbers together and divide by 2. So by adding r and s together and dividing by 2, that gives me the middle number, which is the mean of the x-intercepts. And that will also help me find the axis of symmetry. So the axis of symmetry is in the form of x equals h, whatever that middle number was. The zeros of a relation have the value, I'm going to say that again. The zeros of a relation are the values of x for which a relation has the value of 0. The zeros of a relation correspond to the x-intercepts of a graph. To find the zeros of a relation or a function, we substitute 0 for y and solve for x. We're going to do this in the next examples. Okay, so we're going to, in example 1, we're going to find the zeros of each function. We're going to identify the x and y intercepts of each function's graph and identify if the graph of each function has a vertical stretch or compression or reflection. So I can see right away, looking at my equation, because this is in standard form, that this c value from standard form is the y-intercept. Now, some of you might be wondering, why am I using the letter C for that? It's because I'm relating it to the general form up here. Okay, the general form is in the form of ax squared plus bx plus c. Okay, so again, c is the y-intercept, so what we're going to do next is we're going to work on finding the zeros of the function. So to find the zeros of the function, I'm going to go through these steps. So I wrote down for you on the side here steps for finding x-intercepts, zeros, roots, or solving a quadratic equation. They all have the same steps. Step 1, you're going to set y or f of x equal to 0, so that's the same as setting f of x equals to 0. Then you factor. Then you set each factor equal to 0 and solve for x. Okay, so step 1, we set y or f of x equal to 0. That was step 1. Step 2, we're going to factor. Okay, so I want to use my factoring chart here, and I can see that when we use our factoring chart, we always want to consider common factoring first. And yes, we can common factor, so I'm going to pull out the greatest common factor, which is a 4, and that leaves me with x squared minus 6x plus 9. Now I have a trinomial, so 3 terms, and a is 1. So I can factor this very quickly by finding two numbers that multiply to 9 and add up to negative 6. So I'm looking for factors of 9 that sum to negative 6. The numbers that work are negative 3, negative 3. So I'm going to factor that to x minus 3 times x minus 3. Okay, all of this was step 2, the factoring step. The next thing that I do is I'm going to set each factor equal to 0 and solve. Okay, so in order to understand why we're doing this, let's go back to this box over here. So solving by factoring is based on the zero product property. So if you have two numbers, a and b, and you're multiplying them together and you know the answer is 0, that would mean that either a has to equal 0, your first number has to equal 0, or b has to equal 0. Or both of them have to equal 0. That's the only way to multiply two numbers together and get a 0. So we're going to use that property here. This says 4 times the number times another number is equal to 0. So for that statement to be true, we know that therefore either x minus 3 has to equal 0, my first factor, or the second one has to equal 0. Now this seems a little bit repetitive in this example. You'll see that it's different in the other examples. And now what I do is I solve each of these equations. So I'm solving for x. So I'm going to add 3 to both sides to isolate the x. And I get x equals 3 And since this is identical, when I add 3 to both sides, I get x equals 3 here as well. So I just found the zeros. However, in this case, there's only one zero. So therefore, the zero of the function is 3. Okay, step 2. We were supposed to find the x and y intercepts. Now, we already talked about the y-intercept. We knew very early on that the y-intercept is 36, because that's my c value from standard form. And we just found x-intercepts because the x-intercepts and the zero of the functions are the same values. So the x-intercept is 3. In this case, there's only one. The third thing that we want to do in this question is identify if the graph of each of the functions has a vertical stretch, compression, or reflection. I'm getting this information from A. A is 4. And I'll just jot down that it's positive 4. Okay, so it's a positive value. That means it opens up, so there's not a reflection. So we know that it has a vertical stretch of factor 4. And there is no reflection because A is not a negative number. All right, let's do it again for the second example. So in our second example, we have the equation f of x equals negative 3x squared plus 12x. So in this case, I only have two terms. I don't have that third term. That's because my third term is really this invisible plus 0. So that's my c value. So this gives me here, this invisible plus 0, that's my y-intercept. Now I can also find that y-intercept again by setting x equal to 0, evaluating f of 0. And when I do that, this term would turn into a 0, so will this term, and I'm left with 0. So that's my y-intercept. You could do it either way. All right, so part 1. We are going to find the zeros of the function. So step 1, we set y, or f of x, equal to 0. That was step 1. Step 2, we factor. So in this case, I am again going to start by considering common factoring. Can I common factor? Yes, I can. So I'm going to factor out a negative 3x. That's my greatest common factor. And when I do that, I'm left with x minus 4. So here's my factoring step. And then I'm on step 3. We're going to set each factor equal to 0 and solve. So again, the only way for me to multiply two numbers together and get 0 is if the first number is 0 or the result of the second expression is 0. So therefore, either negative 3x has to be 0 or x minus 4 equals 0. Okay, so this was all part of step 3. I forgot to write that down on this side too. And then we solve each of these equations. So here I want to divide both sides by 3 to isolate the x. And 0 divided by negative 3 is 0. And over here I'm going to add 4 to both sides to isolate x, and I get x equals 4. So we know, therefore, the zeros of the function are 0 and 4. Step 2, or part 2, asks us for the x and y intercepts. Okay, we already talked about the y-intercept. We know that the y-intercept is 0, and the x-intercepts will be the same values as the zeros of the function. Let's think about this for a sec. Why would the x-intercepts and the zeros of the function be the same? Let me go back to the picture from the investigation. The zeros of a function are the x values when y is 0. So when I take a look at my graph, here I can see that y is 0, because there's 0 on the y-axis, at negative 3 and 1. And it's the same as the x-intercepts. So my x-intercepts are 0 and 4. And part 3, is there a stretch, a compression, or reflection? So A is -3 this time. So I know that there's a reflection in the x-axis because it's at negative. And because the magnitude of my A value, that's the distance of the number and 0 on a number line, is 3, I know there's a vertical stretch of factor 3. Okay, we're on the back. So I'm just using different vocabulary, but our steps are actually going to be the same here. So C says to solve the quadratic equation. Now this is already set equal to 0, so I can skip step 1. Solving the quadratic equation, I'm going to do it by factoring. My son is trying to make me laugh here. I'm not going to do it, class. I'm just not going to do it. Okay, so we're finding the factors of -10 that add up to -9. And I'm doing it that way because I am thinking through the factoring chart, and I'm going to use decomposition. So when we, okay, maybe I will laugh. Okay, so when we use decomposition, we're finding factors of A times C that add up to B. And the numbers that work are -10 and 1. So remember to keep using your factoring chart. First step is common factoring. No, we can't common factor. Then we ask ourselves the number of terms. There are 3 terms. And with the 3 terms, A is not 1. That's why I'm choosing decomposition. Okay, so -10 plus 1 is -9. Okay, so quickly with decomposition, I am going to use those 2 numbers to replace my bx terms. So I have -10x plus x. And then I'm going to rewrite that -5 equals 0. I common factor twice. If you have not finished last week's work, you're going to find the solving part in this week's work difficult. You need to do last week's work first. Okay, and then last step for decomposition is I factor again. So here are my 2 terms. I'm going to factor out the x minus 5, and I'm left with 2x plus, there's an invisible 1 here, plus 1. Or you can think of it like this. When I divide both of these terms by x minus 5, that cancels, and it leaves me with a 1. Okay, almost done here. So there's my factoring step. Next step is I set each of these factors equal to 0 and solve. Okay, to solve here, I'm going to add 5 to both sides, and I get x equals 5. And then here we subtract 1 from both sides. We have 2x is equal to -1. And I'm going to finish by dividing both sides by 2 to isolate the x. That cancels and becomes a 1. And I have x equals -1/2. Okay, so the solutions to the equation are x equals -1/2 and x equals 5. Now I could have asked you to find the roots of a quadratic equation. That's just another way of asking you to solve a quadratic equation. Okay, so you would do the exact same steps if I asked you to find the roots. Example 2. What are some of the key features of the function y equals -2x squared plus 200? Well, the easiest thing to see is the y-intercept. So I know that the y-intercept is 200 because this is standard form. It is not factored form. It's in the form of ax squared plus bx plus c. B is 0. That's why you don't see that bx term. My a value is negative, so because a is negative, I know that there is a reflection in the x-axis. The magnitude of a is 2, so that tells me there's a vertical stretch of factor 2. Because a is negative, I know that if I was to graph this, I would get a parabola that opens down and has a maximum value. Okay, what I should also find out are what are the x-intercepts, because those are also key features of that function. So in order to do that, we go through our 3 steps. We're going to find the zeros of the function. I'm going to set y equal to 0 and solve. And we're going to solve this week always by factoring. Okay, step 1 in the factoring chart. Can I common factor? Yes, I can. I can factor out that -2. Remember, when the leading coefficient is negative, you always want to factor out a negative, which leaves me with x squared minus 100. Step 2, you ask yourself how many terms are there. There's 2 terms. The first term is a perfect square. The second term is a perfect square. It's separated by a subtraction sign, so it is a difference of squares. I'm going to factor that difference of squares. So I draw 2 brackets. I put a plus sign in one, a minus sign in the other. The square root of the first term goes in this position, and the square root of the second term goes in this position. Okay, so again, I'll jot down the steps for you. We set y equal to 0. This step is all factoring. And then our third step is we set our factors equal to 0 and solve. Excuse me. So therefore, x plus 10 equals 0, or x minus 10 is equal to 0. And when I solve each of those, I get x equals -10, and I get x equals 10. Sorry. Okay, so those are the x-intercepts. So the other thing that I know is that it has x-intercepts. At -10 and 10. And the last question, or the last part. It says a quadratic function can have 0, 1, or 2 zeros. Relate this to a graph of a quadratic function to explain why this makes sense. Okay, so really think about a graph. So remember, every time we do a video lesson, you should try to do the questions on your own. So you should be pausing the lesson and then resuming it after you've tried it or after you've done calculations. All right, so if we have 0 zeros or 0 x-intercepts, that means that the graph does not cross the x-axis. So your graph could look like this. Your parabola, maybe it opens down, but it doesn't cross the x-axis. So this shows no zeros because the graph has no x-intercepts. The second situation is, what would it look like? What would a graph look like if there was just 1 0 for the function? Well, that means it's just going to touch the x-axis like that. It only touches at one point. So this shows 1 0 because the graph has 1 x-intercept. And often we have 2 zeros or 2 x-intercepts, and that's because our parabola crosses through the x-axis. And again, these could be opening down as well. And we have 2 x-intercepts. So in this case, the function would have 2 zeros, and the graph has 2 x-intercepts. Oops, sorry. I'll just raise this up so you can see that better. Okay, and that's the end for this segment.